Okay, so welcome to this binary video. So basically this course is System Vulnerability Assessment, which is CYS330, and it's a full course done by Mr. Mtunda. So we'll be focusing on the test 2 paper for now. So these are the answers, but I'll be explaining how you can calculate them. So question 1 says an overflow counts for about 23% according to the CVSS of the attack, and therefore requires deep knowledge and understanding in order to easily identify and mitigate it as a vulnerability. So CVSS stands for Common Vulnerability, or by the way, it's a Common Vulnerability Scoring System. Yeah, Common Vulnerability Scoring System, so which has a particular range. So we are not interested in that for now. So this introduces 1's and 2's complement numbers in binary number system, which the computer is believed to be using. Okay, so in this video, focus on 1's and 2's complement in terms of binary and determine whether an overflow has occurred or not. But first of all, we need to understand the term. What's an overflow? So as we all know, an overflow is simply a vulnerability whereby data is overwritten to the adjacent memory, causing the computer to crash or malfunction. So that's what we mean by an overflow. But how can we know if an overflow has occurred in binary? Let's find out. So add the following numbers in 2's complement using 8 bits. Determine whether an overflow has occurred or not. 6 marks. So the key part here is that we are using 8 bits. Okay, so let's start with 8 bits first so that we understand. So by 8 bits, what we mean is that we'll be using the powers of 2. So you have 1. Okay, so what is 1 times 2? Okay, we have 2. So 2 times 2, we have 4. 4 times 2, we have 8. 8 times 2, we have 16. 16 times 2, we have 32. 32 times 2, we have 64. 64 times 2, we have 128. So let's count these numbers. This is 1, 2, 3, 4, 5, 6, 7, 8. So that's what they mean by 8 bits. So this is the powers of 2 principle, whereby 2 to the power 0 is 1, 2 to the power 1 is 2, 2 to the power 3 is 4, all the way to 2 to the power 7, which is 128. So in shorter terms, I was just saying, what is 1 times 2? It's 2. What is 2 times 2? It's 4. 4 times 2, so on up to 128. That's the simplest way you can do that. Okay. Now, since here our question is talking about adding these 2 numbers, now which numbers have we been given? So the first question is we're adding for negative 47 and 19. Now look at the question. Look at the question. The question is saying add those 2 numbers using what? 2's complement. So we have these 2 numbers. We have these 2 numbers, which is, let me change the color. So we have negative 47. What was the other number? Let me just confirm. So the other number was 19. Okay, so we have these 2 numbers. So we are adding. So I'm saying plus 19. Okay, now one thing we need to understand about 2's complement or 1's complement, okay, any complement, 1 or 2, it's that the only number which is affected is the one having a negative. Okay, so in this case 47 is having a negative, so 47 is affected. So it means 19 will be converted in normal binary, but negative 47 will follow 2's or 1's complement. So here we are told to add these two numbers in 2's complement. So let's do that now. So what to do, let me just wrap this. Okay, so let's start converting first 19 into binary, because 19 won't be affected. So 16 plus 2 gives us 18, plus 1 gives us 19. So that's our 19 in binary. So here we'll be replacing with zeros. Okay, so here we'll be replacing everything with zeros. So you can see that 16 plus 2 is 18, plus 1 is 19. So we've converted 19 in binary. What about 47? So for 47, what to do is that we first convert 47 in binary. Okay, so say 32 plus 8. 32 plus 8, it's 40, plus 4, it's 44. Okay, plus 2, 46, plus 1, 47. So there we have our 47. Now take note, we don't want 47 but negative 47. So for us to get negative 47, now we need to apply the complement rules. So for you to find 2's complement, you just say 1's complement plus 1. That's the formula for 2's complement. So here is how we do it. First of all, we need to convert 47 in 1's complement by flipping all the numbers. So zeros becomes 1, 1's become zeros. So this is a 0 to become a 1, this will become a 1, this is a 0 now, this will become a 1, this 0, this one 0, this one 0, and that one 0. So this is 47 in 1's complement. Now to get 47 in 2's complement, we just need to add a 1 after flipping these numbers. So we just need to add a 1. So I'll say plus that 1. So now here we learn how to add binaries. So as we are progressing with the videos, you understand that. So 0 plus 1, we say 1. Then here we don't have a number, so this just becomes a 0, this one becomes a 0, that one is 0, a 1, a 0, a 1, and a 1. Okay, now we have the two numbers which we needed, 19 and negative 47 in 2's complement. Now we can go back to the question. So our question specifically says we need to add negative 47 and 19 in what? 2's complement. Okay, so now what is our negative 47 in binary? So we can see we have a 1, we have a 1, we have a 0, we have a 1 followed by 3 zeros and a 1. So we say 0, 0, 0, and 1. Okay, now here let's just focus on our 19. So it has 3 zeros, so we'll start with 3 zeros, 0, 0, 0. Then after 3 zeros we have 1 and 2 zeros, so we'll say 1, then 2 zeros. Then at the end we can see we have 2 1's, so we'll say 1 and 1. So here you can see we have plus, so here we'll say plus. Then once that is done, we are going to add. So here now find our answer. So 1 plus 1 won't say 2. Okay, here we'll put a 0 and we'll carry a 1. So here is how it works. So if you have 1 plus 1, normally your answer is 2. Okay, now remember binary uses base 2. Okay, so it's the same as what is 2 divided by 2. Okay, so 2 divided by 2, it's 1, but what is the remainder? The remainder is 0. So what we put here at the bottom is the remainder. Then we carry the number of times that number was entering. So in this case, 1 plus 1, we know it's 2, but we say 0, which is the remainder. Then we carry this number of times which 2 enters into 2, which is that. So let's continue. 1 plus 0 plus 1 is the same as 1 plus 1, which is 2. So we know here it's a 0, and then we carry 1. So this one is straightforward. 1 plus 0 plus 0 is just 1. So 0 plus 0 is 0. Then 1 plus 1, we know it's 0. We carry a 1. So this is straightforward. Here it's a 1. This is 1. Then that is 1. So we have our final answer. Now, since we already have this, we can try to prove. Okay, let's imagine we want to add this number normally, like the way we do our normal calculations. So it's more like we have 47 and 19. How does mathematics work? We know that negative and positives give you negative, so we'll be subtracting but getting the sign of a bigger number. Okay, so it's the same as 47 minus 19. Okay, so here we'll remove 1 so that we have 3, and this becomes 17. Okay, so 17 minus 9. So since we are not allowed to use any calculators, we can see that the answer is just 8. Okay, then 3 minus 1, it's 2, giving us 28. Now remember, here we have the bigger number 47 with a negative, so it will be negative 28. Now we can convert 28 in binary, okay, and confirm the answer. So how can we do that? So let me show you a way we can do that again. So we said the 2's complement, we said the powers of 1s start with a 1. Then we said 2, because 1 times 2 is 2, 2 times 2 is 4, 4 times 2 we have 8, 8 times 2 we have 16, 16 times 2 we have 32, then 32 times 2 we have 64, 64 times 2 we have 128. Now our target is to convert negative 28 in 2's complement. Okay, so we first start converting 28. Okay, remember a negative is affected. So here we'll convert 28. We'll say 16 plus 8, it's 24. Plus 4, it's 28. So we have our 28. So we'll say, sorry for that, we'll say 28. Then the rest, these are zeros. Okay, now since this is our 28, remember 2's complement, any negative number which is negative 28 is affected by a complement. So for us to get 2's complement, we said we convert this number in 1's principal first by flipping the number. So zeros becomes 1's. So like that, we've flipped our values, and this is our 28 in 1's complement. Now in 2's complement, we said we add a 1 for us to convert a number in 2's complement. So here we said 1 plus 1, we know we say 0, we carry a 1. Okay, so 1 plus this 1, again it's a 0, we carry a 1. So 1 plus this 0, it's a 1. Here we just have a 0, put a 0. This is a 0, we put a 0. This is a 1, we put a 1. That's a 1, and that's a 1. Okay, now we have these two answers. So this was our normal procedure. We can see that we have 3 1s, 2 zeros, 1 1, 2 zeros. It's the same as this one. Okay, it means officially we have proved that this is negative 28 in 2's complement. So going back to our document, let's just see if that's 2. So where is the final answer? Okay, so we can see that here we are getting negative 28. As I have said, we've converted this number now into 2's complement. So here I'm only interested into the final answer. Let me get rid of this. Okay. So now here what we had to do at first is that we know that this is negative 28. Then we had to convert this 19 into a normal procedure, which is not affected by binary, which is giving us this 19. But remember, 47 was affected by the complement because it's negative number. So what we had to do is that we first converted 47 into a normal binary. Then later on, we had to convert 47 into 1's complement by flipping the numbers. Then we have to add the 1 for it to become 2's complement. Now we get this 2's complement answer and press it here for us to actually add 19 and negative 47 in 2's complement, giving us 3 1's, 2 zeros, just a 1 and 2 zeros. So that's how we do this. So I'll be recording these videos in sessions so that they are not too long. Otherwise, if I explain much, it will be a long video. So this is it for question 1. So my name is Asoko James, representing KMU Cyber Security Tutorials. Hope you enjoy and see you in the next one.